Good evening. We are going to prove that the product of 5 consecutive integers always divisible by 120. If you do the experiment with any 5 consecutive integers, you will find one of them is always multiple of 5. So if I start from here, 5, 6, 7, 8, 9, 10. You see, two of them are divisible by 10. But if we have started with 4, then 4, 5, 6, 7, 8, 9. Now I have taken 6. We must not take 6, we will take 5 only. So these 5, one of these 5 numbers always divisible by 5. If you have taken from there, that 5 to 9, there also one of them is always multiple of 5. This way, if you start from any integer, like suppose suddenly you have started from 17, 18, 19, 20, 21. See, 20 is divisible by 5. But we want to generalize the result. To generalize the result that product of 5 consecutive integers always divisible by 5, there are two ways. One is just by using Euclid's division lemma, and the other one is by using the concept of permutation, combination and factorial notation. Right now I prefer to do it with the help of Euclid's division lemma. You know, integers can always be expressed in the form that is 2q or 2q plus 1 when you consider divisibility by 2. Why? Because a is equal to, if you consider divisibility by 2, a will be equal to 2q plus r, that r may be equal to 0 or 1. Because r is greater than or equal to 0, less than 2, so two integers possible. By putting r equal to 0, you are getting one integer this form and the other one. So either even or odd. Now if somebody says that what is the product of two consecutive integers, in one equal to, suppose you are taking 2q and 2q plus 1, what is the result? This you always can say that always divisible by 2. One of them must be even. Now if you consider divisibility by 3, then integers can be taken in this form, a equal to 3 into q plus r, and r by Euclid's division lemma will be 0, 1 or 2. This time in integers, instead of taking 2q, 2q plus 1, we can take integers of this form, 3q plus 1 and 3q plus 2. So if we consider the product of 3 consecutive integers into, you can see that this is coming to be 3q plus 1, 3q plus 2. So what about the product here? This product is divisible by 3. This is always divisible by 3. Similarly, if you consider divisibility by 4, say you are taking integer a equal to 4q plus r, then values of r going to be 0, 1, 2, 3. And the integers can be taken in this form, 4q or 4q plus 1, 4q plus 2, 4q plus 3. And if we consider product of 4 consecutive integers by writing this as n3, then it is 4q plus 1, 4q plus 2 multiplied by 4q plus 3. You can see that the product this time contains this 4q here and one 4q plus 2 here. So this thing always divisible by 8. One additional thing we must notice, if it is product of 4 consecutive integers, it must be product of 3 consecutive integers first and then the fourth one arise. And we have proved that product of 3 consecutive integers divisible by 3. So when you are saying that this thing divisible by, it will be 4 into 2, that is 8. Now product of 3 consecutive integers always divisible by 3. So one can say that this result is always divisible by 8 into 3, that is 24. And here, when you are saying that product of 3 consecutive integers divisible by 3, it is divisible by 3 into 2 also. Because 2 consecutive integers always there, these two, one of them has to be divisible by 2. Or you take these two numbers, one of them has to be divisible by 2. So their product has to be divisible by 6. So product will be divisible by 6 if it is product of 3 consecutive integers. It will be divisible by 2 if it is product of 2 consecutive integers. It will be divisible by 24 if it is product of 4 consecutive integers. The question is, what will happen if there is product of 5 consecutive integers? So before we prove this, we will keep this in our mind that product of 2 consecutive integers always divisible by 2. Product of 3 consecutive integers always divisible by 3. Product of 4 consecutive integers always divisible by 2 into 3 into 4, that is 24. This is proved already. Now let us see what will happen when you consider product of 5 consecutive integers. To prove that it is always divisible by 5, first we consider divisibility by 5. Integers can be taken in the form of a equal to 5 cube plus r. What about r over there? R is 0, 1, 2, 3, 4. So you can take integers as 5 cube plus 1, 5 cube plus 2, 5 cube plus 3 and 5 cube plus 4. So if we take n4 as product of 5 consecutive integers as 5 cube into 5 cube plus 1, 5 cube plus 2, 5 cube plus 3 into 5 cube plus 4, then it is quite obvious before we consider divisibility by other numbers that one of them has to be divisible by 5, which we were seeing by taking example consecutive 5 numbers. Here by Euclid's division lemma, it is always divisible by 5. Now we have seen that product of 4 consecutive integers. When you consider product of 5 consecutive integers, 4 automatically will be there and they are divisible by 24. So this time here it is going to be divisible by 5 into 4, 24, that is equal to 120. Okay. This way you can prove product of 5 consecutive integers always divisible by 120. 120 is nothing but factorial 5. With the help of factorial notation and little bit sense of permutation and combination, you can prove that in case of 5 consecutive integers, their product always divisible by 120.